Hi, I'm Rachel Jonassen. There's a direct effect of carbon dioxide that you may not have heard of. It's an effect that may be more deleterious to our society than all the others combined, but it has, so far, escaped the attention of most of us. I'm referring to the effect of carbon dioxide upon human cognition. A growing body of professional literature now provides convincing evidence of this effect. Follow along and I'll take you on a tour of the evidence, which is spread throughout the professional literature of disparate disciplines. I'll also relate some evidence that this effect may disproportionately afflict traditionally disadvantaged groups, even as it impacts all of us. But why did that young man fall asleep in class? Evidence from multiple studies suggests that CO2 exercises a deleterious effect on human cognition. For example, the data illustrated here are from Allen et al., 2016. Those researchers measured the effect of elevated CO2 on higher-order cognitive function. In a double-blind experiment with repeated measures at levels of CO2 commonly found in buildings, they concluded that CO2 was independently associated with cognitive scores as measured by the strategic management simulation software. Here you can see the decline in cognitive scores on 3 of those measures of cognitive function at increasing levels of CO2. In some cases, scores changed by a factor of 2 as CO2 varied. Perhaps that young man was suffering from the effects of elevated CO2. Did you ever notice yourself becoming groggy after a short while in a confined room with poor ventilation? But wait, there's more. There's even more evidence that CO2 affects human cognition. In a recent survey of the extensive literature on the subject, drawn from fields as diverse as elementary education, psychology, the heating and ventilation profession, and architecture and building design, studies using a variety of experimental techniques performed in multiple countries with multiple experimental subjects do it all conclude that in a subset of studies that meet objective criteria for strength and consistency, pure CO2 at a concentration common in indoor environments was found to affect high-level decision-making measured by the Strategic Management Simulation Battery, while lower ventilation and accumulation of CO2 could reduce the speed of various functions. On your screen, you see highlights of results of some of those studies. Diaz et al. Report that some students in some classrooms spend over half the day exposed to CO2 levels above 1400 ppm, and CO2 levels are invariably higher in the winter when ventilation is reduced. That CO2 values are higher in more densely packed classrooms and where temperatures are below a comfortable level. As you can see in the diagram, Diaz et al. Measured CO2 concentrations in classrooms as high as 5,000 ppm, with median values well above 1,000 ppm. CO2 is elevated in cities. Numerous authors, beginning with McRae and Gradle in 1979, have identified a phenomenon that has come to be called the urban dome, in which CO2 concentrations measured in and near cities are elevated when compared to the global average. Your location within a city, the time of day, and season all can affect your exposure to CO2. The illustration is taken from Lin et al. BAMS 2018 and shows variations in CO2 concentrations exceeding 20 parts per million along a light rail line in Salt Lake City, Utah. The diagram illustrates how disadvantaged groups are more likely to be exposed to CO2 emissions of power plants. The data are from the EPA. The x-axis shows 6 different demographics of the disadvantaged: low income, people of color, low education, language, children, and elderly. The pairs of box plots for each demographic show the percent of each group making up the population in that region. either the nation at large, as represented in the composition of census tracts throughout the U.S., leftmost of each pair of box plots, or the population living within 3 miles of a power plant, rightmost of each pair of box plots. As you can see from this diagram, for all 6 types of disadvantaged, a higher percentage of the population in the region around power plants tends to be made up of disadvantaged persons than would be expected from a random sample of the U.S. population as represented by the census tract data. Will human cognition suffer? We as a species are already exposed from birth and on a permanent basis to CO2 concentrations significantly exceeding the range of values under which our species evolved. This diagram documents CO2 levels over the past 800,000 years, including the period when modern humans first appeared in the fossil record. The fossil record and genetic evidence point to final differentiation of Homo sapiens sometime between 400,000 and 200,000 years ago. And the ice core record suggests that CO2 levels during this time never exceeded 300 parts per million and ranged as low as 180 parts per million. CO2 levels continued in this range until the middle of the last century. Thus, in a recent phenomena, for humans to be exposed to CO2 levels above 280 parts per million. And for the past 100,000 years, until the last deglaciation, CO2 levels did not exceed 240 parts per million. Since we don't know all of the mechanisms by which CO2 affects cognition, it remains to be examined how quickly such mechanisms might respond to changes in ambient CO2 levels. All of the analyses of the effects of CO2 on cognition are short-term studies and do not examine the possibility that long-term or lifelong exposure to CO2 levels elevated above values under which the species evolved may affect human cognition. At the least, we need to consider that a proper baseline for evaluating short-term effects should be fixed at some agreed standard, such as pre-industrial values, since CO2 concentrations are rising so quickly. For example, a study published in 1988 using data collected in 1987 would have compared outcomes under experimental conditions to baseline values of CO2 concentrations of about 350 parts per million, whereas studies performed in 2021 would have ambient global values of 417 parts per million. It remains to be examined whether human cognitive processes are optimal at levels corresponding to glacial periods, interglacial periods, pre-industrial periods, or other. CO2 concentrations will rise in future. Concentrations of CO2 in the atmosphere are projected to rise to 1,000 parts per million, and perhaps as much as 1,200 parts per million by the end of this century. When combined with the effects of generally elevated CO2 in cities, localized effects within cities, and generally elevated values within buildings, everyone could be regularly experiencing values exceeding 1,500 parts per million. I hope this brief presentation has helped your introduction to the issue of elevated CO2 in human cognition, and I welcome your comments and questions. My contact information is given here should you wish to discuss this further. Thank you.